Use the diagram information and proof to complete. Given segment BA is congruent to segment CA, segment BE is congruent to segment CE, F is on the line AE, prove that the segment BF is congruent to the segment CF. So again, I would duplicate it and just scan to see if I have anything similar to this. We're just proving that segments are congruent. And so, we're proving right here that segments are congruent. We have different things that are given, so this can just be a resource to see if we have any similarities. However, it's not going to be my main go-to. So let's answer this. It says, which answer choices correctly fill in the blanks in the proof? Select two answer choices, select one answer choice for the blank X, and select one answer choice for the blank Y. Okay, so I'm going to read through to statements 4 to see if we can make sense of what the reason would be. Alright. So the distance of BA is congruent to the distance of CA, and the distance of BE is congruent to the distance of CE. That was given right at the very beginning, right here. That means that the distance of BA is equal to the distance of CA, and that the distance of BE is equal to the distance of CE. If they're congruent, that means they have the same length. So that's what this is saying. It says definition of congruent segments, which is correct because congruent segments have the same length. So then it says A is equidistant from B and C. E is equidistant from B and C. Definition of equidistance. Where did that come from? Okay, well, it's saying that BA, right here in this statement, it says that BA is the same distance as CA. And so point A is the same distance to B as it is having to travel to point C. So that's what equidistance means. It means that I have to travel the same distance to reach this point B, and A would have to, you would have to travel from A to point C the same distance. So that is what equidistance is. And right here it says the distance of BE is equal to the distance of CE. So the distance of BE from this point to here is the same distance as point E to point C. And then in statement 3 it says E is equidistant from B and C. That means that from B to E it's the same length as from C to E. So it's the same distance away. Then it says A is on the perpendicular bisector of segment BC, and E is on the perpendicular bisector of BC. Okay, so this is using the perpendicular bisector. However, it is not stating that we started off with a perpendicular bisector. It's working backwards to stating that we are on this line that's a perpendicular bisector. So that is a good clue that is using the converse of the perpendicular bisector theorem, because it is now stating that the line AE is the perpendicular bisector of the segment BC. So that is the converse of the perpendicular bisector. Is first you establish that it's a perpendicular bisector, then you can state and use that. So then now it is stating that F is on the line AE. That is given. Yes, it's given right there up at the top. And it's saying that BF is equal to CF. So it's saying that BF is going to be the same as CF right here. Well, we just established right here in statement 5, that this line is the perpendicular bisector. That means it intersects at line BC at a 90-degree angle, and it cuts it in half. So then all of the other points would be equidistant from it. So now it says, what is the reason that BF is equal to CF? That is because it is on the perpendicular bisector, which point F is on this perpendicular bisector right here. So it's going to cut these lines in half. So Y is perpendicular bisector theorem.